In this example, we're going to see how to find the general equation of a hyperbola if I give you specific elements. So for example, it says the foci at negative 2, 3 and at negative 2, negative 5, okay? If I graph that, that would be my first recommendation. Graph what they're giving you. So at minus 2, minus 2, 3 and at negative 2, negative 5, I have two focus, okay? And it has a lattice rectum of 14 over 3. So first thing, identify what you have. I have two focus. That means that if my focus is here and my focus is here, my center has to be in the middle. And my hyperbola must be a hyperbola that opens vertically. It has to be something, well, obviously not passing through the focus, but it has to be something that opens this way because my foci are here and here, okay? So you've identified the direction in which it opens. You know that between the focus 1 and focus 2, you have the center. And then from there you can start. Now you can find the center. The center is the midpoint between the two focus. To find the midpoint, you have to add the x's of your 2 points divided by 2 to find the x, and the y's of your 2 points divided by 2 to find the y. So if I want the midpoint between this focus and this focus, you would have to add minus 2 plus minus 2 divided by 2, and 3 plus minus 5 divided by 2, and that gives me minus 2, minus 1. This is the center of my hyperbola. Then you know that the distance from the center to the focus, it's the value of c. So how do you find the distance? You know also how to find the distance between 2 points. So you would do minus 2 minus minus 2, which that is positive 2 squared, and then 3 minus minus 5, so that's why it's positive 5 squared. You do that distance and you get that the total distance it's 8. What I'm finding here, guys, it's the distance from one focus to the other. So you know that half of that distance, it's going to be the value of c, therefore c would be 4. You also know that the lattice rectum is 2b squared over a. And I'm giving you the lattice rectum, 14 over 3. So if I isolate b squared, the reason of why I isolate b squared, it's because whenever I use my condition, I'm going to need b squared. So if I isolate b squared from here, the a multiplies and the 2 divides, I end up with b squared being 7a over 3. So what you do is you substitute this b squared that you have right here with the value 7a over 3. And you also have the value of c, so I substitute the value of c, which is what we found, the distance, 4, and I have that 16, it's equal to a squared plus 7a over 3. And this is an equation that you would have to solve. I multiply everything by 3 to get rid of the denominator, so I would have 48, it's equal to 3a squared plus 7a. And then I take everything to one side, so I have 3a squared plus 7a minus 48, it's equal to 0. This is a quadratic equation. So to solve the quadratic equation, in this case, you can factor. I factored into 3a plus 16 and a minus 3 is equal to 0. I equal both of these to 0, and I end up with a being negative 16 over 3 and a being 3. Since a is a distance, guys, we are going to take the positive one. Why can we not take the negative one? First, because it's a distance and distance has to be positive. Secondly, because if I take this a negative and substitute it here in the formula of b squared to find the value of b, you're going to end up with a negative square root, and you cannot find that. So that's why we only take the positive value. So I substitute the 3, and I get that b squared is equal to 7, and therefore b is the square root of 7. Now with this, you can do the rest by identifying the formula that you're going to be working with. If we want to do the vertical hyperbola, because we know that it opens up and down, you would use this equation. I substitute the value of k and the value of h, which is the center, and we already found it. So you would have y minus minus 1, so it's y plus 1 squared, x minus minus 2, which is x plus 2 squared, and then my value of a is 3, so 3 squared is 9, And the value of b is the square root of 7, and the square root of 7 squared will give me 7. I need to eliminate the denominator, so I'm going to multiply everything by 63. I multiply everything by 63 and I end up with 7 times this parentheses minus 9 times this parentheses is equal to 63. You have to expand this binomial, first one squared, plus 2 times the first one times the second one, plus the second one squared. And I get y squared plus 2y plus 1. Same thing with x plus 2 squared. X squared plus 2 times x, it's 4x plus 2 squared. That's 4. And then you just multiply 7 times this parentheses and negative 9 times this parentheses. You get all of this, and then you just make sure that you take this 63 subtracting to the other side, and you get that your equation is 7y squared minus 9x squared plus 14y minus 36x minus 92 equals 0. This right here would be the equation, the general equation of the hyperbola that has focus 1 as negative 2, 3, and focus 2 as negative 2, negative 5, and it has a lattice rectum of 14/3.